Welcome back. It's Friday weekend. I got up again. It's 10 a.m. I have nothing to do today. Read about this Dreamliner. This is the super modern airline passengers aircraft. So I'm not behind any bills. I pay my rent apartment, my bills, payments to my debts. It's Friday number 7, so Monday number 10. I can see how much YouTube money I get in Danish kroners. But that's only few, that's like $350. Maybe $400. That's not enough to go travel. To buy expensive airline tickets, many thousands of dollars. You cannot go travel much, just $400. So I need to get this Microsoft Flight Simulator. We can do some virtual travel in Microsoft Flight Simulator all over the world. I think I have not read this. So that's some kind of medium range from few thousand kilometers to 10,000 kilometers. It's a medium to long range. I think that can fly like 10,000 kilometers. They have a very high speed. Mach 0.9 is one of the fastest. They have a very high cruising speeds. Oh, they can fly super far away. 14,000 kilometers. So they can fly most the same range the Boeing 777. So that's very impressive. Super long range. A lot more than 10,000 kilometers. So let's read about it.
Boeing 787 Dreamliner. Not to be confused with Boeing Dreamlifter. Dreamliner redirects here. For the Boeing song, see Dreamliner, song. The Boeing 787 Dreamliner is an American wide-body airliner developed and manufactured by Boeing Commercial Airplanes. After dropping its unconventional Sonic Cruiser project, Boeing announced the conventional 787 on the 29th of January, 2003, which focused largely on efficiency. The program was launched on the 26th of April, 2004, with an order for 50 aircraft from All Nippon Airways, ANA, targeting a 2008 introduction. On the 8th of July, 2007, a prototype 787 without major operating systems was rolled out. Subsequently, the aircraft experienced multiple delays, until its maiden flight on the 15th of December, 2009. Type certification was received in August 2011, and the first 787-8 was delivered in September 2011 before entering commercial service on the 26th of October 2011, with ANA. At launch, Boeing targeted the 787 with 20% less fuel burn than replaced aircraft like the Boeing 767, carrying 200 to 300 passengers on point-to-point routes up to 8,500 nautical miles, UMI, 15,700 kilometers, 9,800 mi, a shift from hub and spoke travel. The twinjet is powered by General Electric GX or Rolls-Royce Trent 1000 high bypass turbofans. It is the first airliner with an airframe primarily made of composite materials and makes greater use of electrical systems. Externally, it is recognizable by its four-window cockpit, raked wingtips, and noise-reducing chevrons on its engine nacelles. Development and production rely on subcontractors around the world more than for previous Boeing aircraft. Since March 2021, final assembly has been at the Boeing South Carolina factory. It was formerly in the Boeing Everett factory in Washington. The initial 186-foot-long, 57 m, 787-8 typically seats 248 passengers over a range of 7,305 mi, 13,529 kilometers, 8,406 mi, with a 502,500 pound, 227.9 t, NTO compared to 560,000 pound, 250 t, for later variants. The stretched 787-9, 206 feet, 63 m, long, can fly 7,565 mi, 14,010 kilometers, 8,706 mi, with 296 passengers. It entered service on the 7th of August, 2014, with All Nippon Airways. The further stretched 787-10, 224 feet, 68 m, long, seating 336 over 6,313 mi, 11,720 kilometers, 7,280 mi, entered service with Singapore Airlines on the 3rd of April, 2018. Early 787 operations encountered several problems caused mainly by its lithium-ion batteries, including fires on board some aircraft. In January 2013, the US FAA grounded all 787s until it approved the revised battery design in April 2013. Significant quality control issues from 2019 onward caused a production slowdown and, from January 2021 until August 2022, an almost total cessation of deliveries. Boeing has spent $32 billion on the program. Estimates for the number of aircraft sales needed to break even vary between 1,300 and 2,000. As of December 2024, the 787 program has received 1,957 orders and made 1,161 deliveries with no fatalities and no hull losses. Development, edit. Background, edit. During the late 1990s, Boeing considered replacement aircraft programs due to slowing sales of the 767 and 747-400. Two new aircraft were proposed. The 747X would have lengthened the 747-400 and improved efficiency, and the Sonic Cruiser would have achieved 15% higher speeds, approximately Mach 0.98. while burning fuel at the same rate as the 767. Market interest for the 747X was tepid. Several major American airlines, including Continental Airlines, showed initial enthusiasm for the Sonic Cruiser, although concerns about the operating cost were also expressed. The global airline market was disrupted by the 9/11 attacks and increased petroleum prices, making airlines more interested in efficiency than speed. The worst affected airlines, those in the United States, had been considered the most likely customers of the Sonic Cruiser. Thus the Sonic Cruiser was officially cancelled on the 20th of December 2002. On the 29th of January, 2003, Boeing announced an alternative product, the 7E7, using sonic cruiser technology in a more conventional configuration. The emphasis on a smaller mid-size twinjet rather than a large 747 size aircraft represented a shift from the hub-and-spoke theory toward the point-to-point theory, in response to analysis of focus groups. Randy Basler, Boeing Commercial Airplanes VP Marketing, stated that airport congestion comes from large numbers of regional jets and small single aisles, flying to destinations where a 550-seat Airbus A380 would be too large. To reduce the number of departures, smaller airplanes can increase by 20% in size and airline hubs can be avoided with point-to-point transit. In 2003, a recent addition to the Boeing Board of Directors, James McNerney, who would become Boeing's chairman and CEO in 2005, supported the need for a new aircraft to regain market share from Airbus. The directors on Boeing's board, Harry Stone Cipher, Boeing's president and CEO, and John McDonnell issued an ultimatum to develop the plane for less than 40% of what the 777 had cost to develop 13 years earlier, and build each plane out of the gate for less than 60% of the 777's unit costs in 2003, and approved a development budget estimated at $7 billion, as Boeing management claimed that they would require subcontractors to foot the majority of costs. Boeing Commercial Airplanes President Alan Mulally, who had previously served as general manager of the 777 programs, contrasted the difference in the approval process by the board between the 777 and 787, saying, "In the old days, you would go to the board and ask for X amount of money, and they'd counter with Y amount of money, and then you'd settle on a number, and that's what you'd use to develop the plane. These days, you go to the board, and they say, here's the budget for this airplane, and we'll be taking this piece of it off the top, and you get what's left, don't fuck up." The replacement for the Sonic Cruiser project was named 7E7, with a development code name of Y2. Technology from the Sonic Cruiser and 7E7 was to be used as part of Boeing's project to replace its entire airliner product line, an endeavor called the Yellowstone Project, of which the 7E7 became the first stage. Early concept images of the 7E7 included rakish cockpit windows, a dropped nose, and a distinctive shark fin tail. The E was said to stand for various things, such as efficiency or environmentally friendly. In the end, Boeing said it stood for 8. In July 2003, a public naming competition was held for the 7E7, for which out of 500,000 votes cast online the winning title was Dreamliner. Other names included Ilia, Global Cruiser, and Strata Climber. All Nippon Airways launched the 787 program with an order for 50 aircraft in 2004. On the 26th of April, 2004, Japanese airline All Nippon Airways, ANA, became the launch customer for the 787, announcing a firm order for 50 aircraft with deliveries to begin in late 2008. The ANA order was initially specified as 3,787 to 3, 293 30-seat, one-class domestic aircraft, and 2,787 to 8, long-haul, 210 to 50-seat, two-class aircraft for regional international routes such as Tokyo Narita to Beijing capital, and could perform routes to cities not previously served, such as Denver, Moscow, and New Delhi. The 787 to 3 and 787 to 8 were to be the initial variants, with the 787 to 9 entering service in 2010. On the 5th of October, 2012, Indian state carrier Air India became the first carrier to take possession of a Dreamliner that was manufactured in the Charleston, South Carolina, Boeing plant. This was the first Boeing Dreamliner that was manufactured outside of Washington state. Boeing would go on to use both the Everett and South Carolina plants to deliver the Dreamliner. The 787 was designed to be the first production airliner with the fuselage comprising one-piece composite barrel sections instead of the multiple aluminum sheets and some 50,000 fasteners used on existing aircraft. Boeing selected two new engines to power the 787, the Rolls-Royce Trent 1000 and General Electric GX. Boeing stated the 787 would be approximately 20% more fuel efficient than the 767, with approximately 40% of the efficiency gained from the engines, plus gains from aerodynamic improvements, increased use of lighter weight composite materials, and advanced systems. The airframe underwent extensive structural testing during its design. The 787-8 and 9 were intended to have a certified 330-minute tops capability. During the design phase, the 787 underwent extensive wind tunnel testing at Boeing's Transonic Wind Tunnel, Kinetics 5-meter wind tunnel at Farnborough, United Kingdom, and NASA Ames Research Centre's wind tunnel, as well as at the French Aerodynamics Research Agency, ONERA. The final styling was more conservative than earlier proposals, with the fin, nose, and cockpit windows changed to a more conventional form. By 2005, customer announced orders and commitments for the 787 reached 237 aircraft. Boeing initially priced the 787-8 variant at $120 million, a low figure that surprised the industry. In 2007, the list price was $146,151.5 million for the 787-3, $157,167 million for the 787-8, and $189,200 million for the 787-9. Manufacturing and suppliers, edit. On the 16th of December, 2003, Boeing announced that the 787 would be assembled in its factory in Everett, Washington. Instead of conventionally building the aircraft from the ground up, the final assembly employed 800 to 1,200 people to join completed sub-assemblies and integrate systems. Boeing assigned global subcontractors to do more assembly work, delivering completed sub-assemblies to Boeing for final assembly. This approach was intended to result in a leaner, simpler assembly line and lower inventory, with pre-installed systems reducing final assembly time by 3/4 to 3 days. Subcontractors had early difficulties procuring needed parts and finishing sub-assemblies on schedule, leaving remaining assembly work for Boeing to complete as traveled work. In 2010, Boeing considered in-house construction of the 787-9 tail. The tail of the 787-8 is made by Alenia. The 787 was unprofitable for some subcontractors. Alenia's parent company, Finmeccanica, had a total loss of €750 million on the project. Subcontracted assemblies included wing and center wing box, Mitsubishi Heavy Industries, Japan, Subaru Corporation, Japan, horizontal stabilizers, Alenia Aeronautica, Italy, Korea Aerospace Industries, South Korea, fuselage sections, Global Aeronautica, Italy, Boeing, North Charleston, US, Kawasaki Heavy Industries, Japan, Spirit Aerosystems, Wichita, US, Korean Air, South Korea, passenger doors, Lateco Air, France, cargo doors, access doors, and crew escape door, Saab, Sweden, software. Development, HCL Enterprise, India, floor beams, TAL Manufacturing Solutions Limited, India, wiring, Labinal, France, wingtips, flap support fairings, wheel well bulkhead, and longerons, Korean Air, South Korea. Landing gear, Messier Bugatti, UK /France, and power distribution and management systems, air conditioning packs, Hamilton Sunstrand, Connecticut, US. To speed up deliveries, Boeing modified 4 used 747-400s into 747 Dreamlifters to transport 787 wings, fuselage sections, and other smaller parts. Japanese industrial participation was key to the project. Japanese companies co-designed and built 35% of the aircraft, the first time that outside firms played a key design role on Boeing airliner wings. The Japanese government supported development with an estimated $2 billion in loans. On the 26th of April, 2006, Japanese manufacturer Toray Industries and Boeing signed a production agreement involving $6 billion worth of carbon fiber, extending a 2004 contract. In May 2007, the final assembly on the first 787 began at Everett. Boeing worked to trim excess weight since assembly of the first airframe began. In late 2006, the first 6 787s were stated to be overweight, with the first aircraft being 5,000 pounds, 2,300 kilograms, heavier than specified. The seventh and subsequent aircraft would be the first optimized 787-8s expected to meet all goals. Accordingly, some parts were redesigned to include more use of titanium. In July 2015, Reuters reported that Boeing was considering reducing the use of titanium to reduce construction costs. Early build 787s, line numbers under 20, were overweight, increasing their fuel burn and reducing their maximum range, and some carriers decided to take later aircraft. Boeing struggled to sell these aircraft, eventually offering significant discounts and scrapping one. Because of their line numbers, these aircraft were nicknamed the Terrible Teens. The first public appearance of the 787 on the 8th of July 2007. Boeing planned the first flight by the end of August 2007 and premiered the first 787, registered N787BA, at a rollout ceremony on the 8th of July 2007. The 787 had 677 orders at this time, which is more orders from launch to rollout than any previous wide-body airliner. The major systems were not installed at the time. Many parts were attached with temporary non-aerospace fasteners requiring replacement with flight fasteners later. In September 2007, Boeing announced a 3-month delay, blaming a shortage of fasteners as well as incomplete software. On the 10th of October 2007, a second 3-month delay to the first flight and a 6-month delay to first deliveries were announced due to supply chain problems, a lack of documentation from overseas suppliers, and flight guidance software delays. Less than a week later, Mike Bear, the 787 program manager, was replaced. On the 16th of January 2008, Boeing announced a third 3-month delay to the first flight of the 787, citing insufficient progress on traveled work. On the 28th of March 2008, to gain more control over the supply chain, Boeing announced plans to buy out aircraft industry's interest in Global Aeronautica. A later agreement was also made to buy Vought's factory in North Charleston. On the 9th of April 2008, a fourth delay was announced, shifting the maiden flight to the fourth quarter of 2008, and delaying initial deliveries by around 15 months to the third quarter of 2009. The 787-9 variant was postponed to 2012 and the 787-3 variant was to follow at a later date. On the 4th of November, 2008, a fifth delay was announced due to incorrect fastener installation and the Boeing machinists' strike, stating that the first test flight would not occur in the fourth quarter of 2008. After assessing the program schedule with suppliers, in December 2008, Boeing stated that the first flight was delayed until the second quarter of 2009. Airlines, such as United Airlines and Air India, stated their intentions to seek compensation from Boeing for the delays. A secondary factor in the delays faced by the 787 program was the lack of detailed specifications provided to partners and suppliers. In previous programs Boeing had supplied high-level design data, but for the 787, decided to provide broad-level specifications only, on the assumption that relevant partners had the competencies to perform the design and integration work with the limited data. This decision created several delays as suppliers struggled to work with the limited design data. Pre-flight ground testing, edit. As Boeing worked with its suppliers toward production, the design proceeded through a series of test goals. On the 23rd of August, 2007, a crash test involving a vertical drop of a partial composite fuselage section from about 15 feet, 4.6 m, onto a 1 in, 25 mm, thick steel plate occurred in Mesa, Arizona. The results matched predictions, allowing modeling of various crash scenarios using computational analysis instead of further physical tests. While critics had expressed concerns that a composite fuselage could shatter and burn with toxic fumes during crash landings, test data indicated no greater toxicity than conventional metal airframes. The crash test was the third in a series of demonstrations conducted to match FAA requirements, including additional certification criteria due to the wide-scale use of composite materials. The 787 meets the FAA's requirement that passengers have at least as good a chance of surviving a crash landing as they would with current metal airliners. On the 7th of August, 2007, on-time certification of the Rolls-Royce Trent 1000 engine by European and US regulators was received. The alternative GE GEnx 1B engine achieved certification on the 31st of March, 2008. On the 20th of June, 2008, the first aircraft was powered up, for testing the electrical supply and distribution systems. A non-flight-worthy static test airframe was built, on the 27th of September, 2008. The fuselage was successfully tested at 14.9 psi, 103 kPa, differential, which is 150% of the maximum pressure expected in commercial service. In December 2008, the 787's maintenance program was passed by the FAA. On the 3rd of May 2009, the first test 787 was moved to the flight line following extensive factory testing, including landing gear swings, systems integration verification, and a total run-through of the first flight. On the 4th of May 2009, a press report indicated a 10–15% range reduction, about 6,900 mi, 12,800 kilometers, 7,900 mi, instead of the originally promised 7,700 to 8,200 nautical miles, 14,300 to 15,200 kilometers, 8,900 to 9,400 mi, for early aircraft that were about 8% overweight. Substantial redesign work was expected to correct this, which would complicate increases in production rates. Boeing stated the early 787-8s would have a range of almost 8,000 mi, 15,000 kilometers, 9,200 mi. As a result, some airlines reportedly delayed deliveries of 787s to take later planes that may be closer to the original estimates. Boeing expected to have the weight issues addressed by the 21st production model. On the 15th of June, 2009, during the Paris Air Show, Boeing said that the 787 would make its first